Hi, I'm Andy, and this is my lesson on private methods in Java. In this lesson, I'll first show you how to use a private method to eliminate duplicated code from a class. I'll also show you how to use private methods to break a complicated task into several simpler tasks. Let's get started. Let's continue working on the rectangle class from previous lessons. Suppose we want to print a warning whenever a user creates a rectangle that is too big. To do that, let's first make a constant called recommended max area. Remember, the static keyword here means that this value pertains to the entire rectangle class. Different rectangle objects will not have different values for this constant. We need to check the rectangle's area in 3 different places in our rectangle class. Here, in this constructor when the rectangle is first created, and also here in this resize method, and here in our other resize method. But remember, we don't want to put the area checking code in all 3 places. That would clutter up those sections of our program with additional code, making them harder to read and longer than they have to be. Plus, if we ever wanted to modify anything about how the rectangle's area gets checked, we'd have to remember to change the code in all 3 places. That's why duplicating code in a program is such a bad idea. Instead, we'll put all that code in just one place, inside its very own method. But this method is different from the others we've created thus far. This method will only be used by other methods and constructors in this class. It won't be called by code outside this class. To enforce this restriction, we make the method private. Remember, private essentially means cannot be accessed by outside code. Then we put the return type. This method won't return any information, so we'll put void as its return type. The name of the method will be check area, and it doesn't have any parameters. In the method body, let's have the method print a warning message if the area is greater than the max recommended area. To do that, we need to calculate the rectangle's area. We already have a method called area that does exactly that. Normally, to call a method, we put the reference variable and a dot in front of the method name. In this case, however, the object will be calling the area method on itself. To do that, we just put the method name without a reference variable or a dot. Remember, methods are commands issued to objects to do something. When you leave off the reference variable and the dot, the object that is executing the original method, check area in our case, will be the one that executes the new method, area in our case. Now we can check to see if the area is too big, and if so, print a warning message. If not, this method doesn't need to do anything, so we don't need an else statement here. Now that check area is complete, let's add it to our constructor and resize methods. Now if we ever want to change how the area gets checked, we simply have to modify the check area method. No other code would need to be changed at all. Let's go ahead and briefly test this out by first making a rectangle that is not too big and then resizing it so it is too big. Good, so that seemed to work well. It looks like the warning was printed only when the rectangle was resized. So that's one use of private methods. The second purpose of private methods is to assist with a process called method decomposition. That process helps us solve a large, difficult task by first breaking it into smaller, simpler tasks and then writing private methods to accomplish each of those small tasks. That probably sounds confusing, so let me show you an example. Suppose we want to add a method to our class that calculates how many circles of a given radius will fit in the rectangle. Here's what I mean. This rectangle has a length of 20 and a width of 16. Suppose we wanted to see how many circles of radius 3 we could fit in the rectangle. As you can see, we can fit 6 circles in the rectangle, so we'd want our method to return 6 in this case. This is a fairly complicated task. To accomplish this task, we'll break it into 3 smaller, easier tasks. I'll outline the sequence of those tasks by using comments. First, we need to find the number of circles in each row, meaning the number of circles that can fit along the length of the rectangle. Then we need to find the number of rows that will fit along the rectangle width. Lastly, we need to use those 2 pieces of information to find the total number of circles that can fit in the rectangle. Now let's add the code for each of our 3 smaller tasks. For the first task, we'll use a private method called getNumCirclesPerRow. It will have one parameter, the circle's radius, and it will return an integer. Notice that the circle radius passed into the getNumInteriorCircles method right here gets passed along in the call to getNumCirclesPerRow right here. For the second task, we'll use a private method called getNumRows. It will also need to be passed the circle's radius and will also return an integer. The last task is actually very straightforward, so we won't do it in a separate method. We'll just put the calculation right here at the end of this method and return its result. Now to finish our original complicated method, we simply need to write the code for these 2 relatively easy methods. We'll start with the getNumCirclesPerRow method. First, let's find the circle's diameter. Then we want to know how many of these diameters fit along the rectangle's length. That's exactly what integer division tells you. So we'll find the circles in a row by dividing the rectangle's length by the circle's diameter. Then we'll return that result. Now let's calculate how many rows of circles will fit in the rectangle. That's a very similar calculation, except we want to know how many diameters fit along the rectangle's width in this case. Okay, that's it. It should all work now. Let's test this out for a 20 by 16 rectangle and a circle radius of 3. Uh-oh, it looks like we got a couple of compilation errors. That's because, right here and here, we're dividing a double, length and width, by an integer, diameter. When you do that, you get a double. Yet we're trying to store that result into an integer variable. To fix these two errors, we'll cast our division result to an int before assigning it to the integer variables. Okay, let's see if it works now. Great. So that's how you perform a complicated task by breaking it into simpler ones using private methods. This is a very powerful programming technique that makes writing complex methods much simpler. And that wraps up this lesson on private methods in Java. I'm Andy. Thanks for watching and coding with me today.